Welcome back, everyone. This is Dr. Gallenstein again, and today we will do the fourth and final lecture in a sequence of lectures on equilibrium and efficiency. So in this lecture, what I'm going to do is I'm going to lay out a problem, a math problem, and we're going to solve for an efficient equilibrium. We're going to solve for an equilibrium. Okay? And we're basically going to solve for the equilibrium that our two-person, two-good, pure exchange economy would find. And so basically, we're going to have an economy that has two people, two goods. It's pure exchange. That means there's no production. All right. And what we're going to do is we're going to set this problem up, and then we're going to solve for it ourselves. Okay, so let's begin with the setup for the problem. And also, as we go through this, we'll hopefully kind of reinforce some of the concepts that we have talked about so far in this series of lectures. Okay, so basically we have two people, and there are two goods. There are two goods, which we'll say, again, are C and B, cereal and bagels. Okay. And so we have two people. Both of them start with an initial endowment. So person one's initial endowment will be 8 bowls of cereal and 2 bagels. Person two's initial endowment will be 2 bowls of cereal and 8 bagels. Okay. Person one will also have a utility function. They'll derive utility from C and B. And so that is, this will be their utility function. All right, where C1 means person one's consumption of cereal, B1 means person one's consumption of bagels. All right, person two will also have a utility function like this. Okay, so now what we're going to do, we're going to use this information and we're going to solve for an equilibrium. Well, what is an equilibrium? We mentioned this earlier, in an earlier lecture, but we'll just reframe it here. An equilibrium is a set of values. Equilibrium is how much cereal person one will consume, how much cereal person two will consume, how many bagels person one will consume, how many bagels person two will consume, the price at which cereal sells, and then the price of bagels. All right, so when we know all of these things, we will have our answer. This is an equilibrium. We will have our answer when we solve for all 6 of these values. All right, so this is the basic setup. When we solve this model, when we find the equilibrium, what we're going to do is we are going to solve for the equilibrium using 7 steps. Okay, so we're just going to go through them one. So we're just going to walk through this and solve it step by step. So step 1. So step 1. What we need to do is establish our budget constraint. Okay. Now, what does a budget constraint look like in a pure exchange economy? Now, you may remember from the past when we've done utility maximization, we said that people will choose cereal and bagels to maximize their utility, subject to some budget constraint where they have some income I, and it's equal to how much money they spend on cereal plus how much money they spend on bagels. Okay, but the question is, in this case, what is income? Because we don't really have income in this economy. This is a pure exchange economy. People don't have income. People start with initial endowments. So what we want to do is we want to establish what is our budget constraint going to be in this two-person economy. Well, that's what we'll do first. That's step 1. The first thing, we begin by defining what the income is. What is person one's income? Well, person one's income is basically the value of their initial endowment. What is the value of their initial endowment? Well, it would be the price of cereal times whatever their initial endowment of cereal is. So I'm going to use this W1C, where the C indicates the good. It's not an exponent. And then it's a superscript, not an exponent. And 1 is the person. Okay, so this would be person one's initial endowment of cereal plus the price of bagels times person one's initial endowment of bagels. So this would basically be the total value of their initial endowment. If we wanted to use the values that we know that person one starts off with 8 bowls of cereal and 2 bagels. So this would be PC8 plus PB2. All right, but we'll stay generic for now. So basically, we consider their income to be the total value of their initial endowment. The total value of their initial endowment is the quantity of the initial endowment times the price of that initial endowment. Okay. All right, person two's income is going to be the same thing, except with person two's initial endowment. Okay, so if this is what income is, then what are the budget constraints? So person one's budget constraint, I'll say BC. So person one's budget constraint is this. It is their income Their income will equal how much they spend on the goods. This is person one, person two. And person one's consumption of cereal plus the value of person one's consumption of bagels. Okay? Person two's budget constraint will follow the same pattern. Okay, so I'm just going to move this to the side, create some space for this, and we'll put it up here. So person one's budget constraint will be PCWC plus the price, so basically the value of their initial endowment, okay? And then that's going to be equal to the money they spend on cereal plus the total amount of money they spend on bagels. Okay, so that's person one's budget constraint. And then person two's budget constraint will be this. Now notice here that both agents face the same prices. So whereas we have person one's initial endowment and person one's consumption, we don't have person one's price and person two's price. They both face the same price. There's only one price in the economy. Okay, so that's step one, budget constraint. So we've now defined that. Step two. We're going to just do a little bit of a math trick here to make the math or to make the algebra easier. So far we started off where we have two prices. We have PC, the price of cereal, and we have PB, the price of bagels. What we're going to do is we're going to do something called normalize the price. And this is it's a nifty trick that helps to make the math easier. We're going to normalize the price. What we're going to do is we're basically going to say this. We are going to divide both prices by one of the prices. So instead of having PC, we'll have PC divided by PB. Instead of having PB, we'll have PB divided by PB. And what this implies is that instead of having PC and PB, we will now have PC divided by PB and then 1. So what we've done is we have normalized the price of bagels to 1. And then what we're going to do is we're just going to define, we're going to say that PC over PB is equal to just P. Now P can be understood as the relative price. So the relative price of cereal. So that is the price of cereal relative to, I think I have that backwards, the price of cereal relative to the price of bagels. Okay, so instead of having PC and PB, we will replace it with P and 1. Now that's actually kind of convenient because what we've done by normalizing the price, we've actually solved for one of our final answers. All right, so up here, as we solve for these different terms, I'll add them as we solve for them. So actually, we have PB, and PB is 1. All right, so that's convenient. What we've done is we've already solved for one of our 6 values. All right, the price of PB is normalized to 1. Okay, so normalized prices. So that means for the rest of the math, every time that we come up against PB, it'll just be replaced with 1. And every time we come up against, or every time we see PC, we will replace it with just P. Now all we have to do is solve for that 1P. That's convenient. Okay, that's step 2. All right, the next one, step 3. Step 3, we're going to establish our market clearing conditions. Step 3, market clearing conditions. Now remember when I mentioned in the past that in an economy at equilibrium, all of the goods are going to be consumed. Nothing goes to waste. All right? What does it mean if nothing goes to waste? What that means is that all of the goods in the economy will be consumed. Well, what we need to do is establish some conditions that guarantees that that will be the case. All right? Those are called the market clearing conditions. Basically what we're saying is this. The amount of cereal that is consumed in the economy will be equal to the total amount of cereal in the economy. So how much is the total amount of cereal in the economy? Well, it is person 1's initial endowment of cereal plus person 2's initial endowment of cereal. And so if we say that the amount of cereal that is consumed is equal to the total amount in the economy, then that means this needs to be equal to the amount of cereal that person 1 consumes plus the amount of cereal that person 2 consumes. Likewise, we can do the same thing for person 2. The same thing for bagels. The total amount of bagels in the economy is person 1's bagels plus person 2's initial endowment of bagels. And this has to be equal to the amount of bagels that person 1 consumes plus the amount of bagels that person 2 consumes. We can simplify this by clearly seeing that we actually can already plug the numbers in and see that this is 8 plus 2. And so this simplifies to 10 equals C1 plus C2. And then this equals 10. 10 B1 plus B2. Okay, so basically we're saying that at the end of the trading, the total amount of cereal that's consumed and the total amount of bagels that are consumed are both equal to 10. Because that's the total amount of the goods in the economy when we look at the initial endowment. Okay, so that's step 3. We have to establish the market clearing conditions. All right, these 3 steps are basically preliminary steps. When we finish with that, what we need to do next is we need to begin to solve the maximization problem. Now let me outline what this looks like. Step 4 is we are going to solve person 1's utility maximization problem. Step 5, we're going to solve person 2's utility maximization problem. Step 6, we are going to solve for the price. We're going to figure out what the price is. In step 7, using P star, we will solve for all of the remaining values that we need to solve for. Okay, so those are the steps. We can get some intuition on this. Basically what we're saying is that the way that the market reaches this equilibrium is that both agents are trying to maximize their utility. And as both agents seek to maximize their utility, prices will be set such that both agents are able to maximize their utility subject to the constraint of what they're able to achieve given their initial endowment. Okay, so both agents are trying to maximize their utility. Remember, they're rational agents. They're trying to maximize their utility. Now, they maximize their utility by entering into trades with the other person. So these two agents are both maximizing their utility. And then the prices will be set such that the market is able to reach an efficient equilibrium. Okay, so that's kind of the intuition here. All right, so let's do this. Let's go step by step, and we'll solve this out. Step 4. Max U1. Okay, I'm going to write small. I might even fit all of this on here. Let's see if we can do it. All right, so now we're going to solve for person 1's consumption of cereal and bagels. All right, let's do it. So we're going to do choose cereal and bagels to maximize utility subject to the constraint of the budget constraint. All right, and so P W1C plus W1P. Remember, I'm normalizing the prices, so the prices are normalized here. PC1 plus B1. All right. Now, to solve this maximization problem, we need to set up the Lagrangian. And I'm also going to plug in all the relevant values. Okay, so it would be natural log of C1 plus natural log of B1 plus lambda. Okay, and then so it's income, so P times 8 plus 2, right? I'm just plugging these values in, minus PC1 minus B1. All right, so this is my budget constraint with the initial endowments plugged in. Okay, so now let's solve this. Derivative of L with respect to C1. All right, so natural log of C1 is 1 over C1. Derivative of this is 0 because there's no C in it. Then we look at this, and the derivative is lambda P. All right, set it equal to 0. Derivative of L with respect to B1, 1 over B1 minus lambda, 0. Derivative of L with respect to lambda, and we will have our budget constraint. Set it equal to 0. Okay. So now what we're going to do is we're going to solve these for C1 and B1. All right, I'll skip a few steps. I think we've done this a couple times now, so I think we'll start to get comfortable with it. Okay. Plug these into the budget constraint, or the last first order condition. Plug those in. 2 minus P times 1 over lambda P minus 1 over lambda equals 0. Okay, the P's cancel out. 8 plus 2 minus 2 over lambda equals 0. Okay, now let's solve this for lambda. We'll get negative 2 over lambda equals negative P8 minus 2. Multiply sides by lambda. Multiply both sides by negative lambda, and then divide both sides by P8 plus 2, and we will get lambda, this is lambda star, equals 2 divided by P8 minus 2. All right, this is lambda star. It's a function only of the parameters, not of the any variables. So this is lambda star. Okay, and now we can simplify this. We'll leave it unsimplified for now, but we could simplify it if we wanted. All right, we'll take this, plug this into C1 and B1 to get our final answer. Okay, so 1, and this will be 2 divided by P8 minus 2 times P. All right, this will be P8. Sorry, this will be plus. All right, plus divided by 2P. All right, and then B1, we will plug the lambda back in, and it's just 1 over 2 over P8 plus 2. All right, so that simplifies to P8 plus 2 over 2. All right, so those are our optimal consumption of cereal and bagels for person 1. All right, now you'll notice that they are still functions of P. That means later we're going to solve for the price and plug it back in, and that will be how we know what their final consumption will be. Okay, so there's step 4. We've solved it. Here are our answers that we were looking for. Okay, but we're not totally done yet because we need to solve for P and plug P back in. We'll get to that in the next step. Now, just to give myself some more space, I'm going to erase this and just write those intermediate answers. Okay. So I'm just going to write these intermediate answers here. C1 star, not the final version because we still have P in there. We need to get rid of P. We'll do that later. All right, B1 star plus 2 divided by 2. Okay, all right, so that's step 4. Let's do step 5. Do the same thing, but with person 2. Let's do the same thing for person 2. All right, we'll just jump straight to the Lagrange. In this case, we'll just jump straight to the Lagrange. Okay. Natural log of P2, okay, plus, now person 2's budget constraint is P times their initial endowment of W plus their initial endowment of bagels minus PC2 minus B2. Okay. All right, now we can do the same process. All right. C2. All right. The math is almost identical, and so it's a good opportunity to get some practice. All right. I'm going to do it very quickly, but when you're doing it, you can slow the video down or whatever you'd like to get some more practice. Okay, 2 lambda, plug this in. All right, plus 8 minus 2 lambda equals 0. All right, lambda equals, so we take the lambda, we take this to the other side, multiply both sides away. Negative lambda, divide both sides, and we'll get 2 over P2 plus 8. This will be lambda star. Plug this back into here, so we get C2 star equals 1 over 2 divided by P2 plus 8 times P is P2 plus 8 divided by 2P. B2 star equals 1 over 2 over P2 plus 8 equals P2 plus 8 divided by 2. All right, so there we go. There's step 5. We've solved person 2's utility maximization problem. All right, we're still not totally done because we need to get prices. So basically, these expressions here are person 1 and person 2's optimal consumption of cereal and bagels conditional on the prices, all right, as functions of the prices. Okay. All right. Now, step 6. We're going to use these 4 conditions. We're going to use these 4 conditions to find the price. Now, how are we going to do that? Well, what we're going to do is we're going to notice that there's only one price. So we just need to find one equation that we can solve, that we can use to solve for the price. Well, there's one straightforward way of doing this. We will use the market clearing condition. We use one of the market clearing conditions. We don't need both. We'll use one of the market clearing conditions. We'll plug these values in and solve for the price. So let's do that. 10 equals B1, 8 plus 2 divided by 2, plus B2. All right, so what's happening here intuitively? What we're saying is that the total consumption of bagels has to equal 10 in the economy because the market has to clear. We have to consume all of it. And so we're going to use these equations to solve for P. I see. So let's do that. All right, multiply the whole thing through by 2. It's 20. P8 plus 2 plus P2 plus 8. Solve that out. 20 equals 10 times P plus 10. Divide through by 10. And you'll get P plus 1 minus 1, and you'll get P equals 1. All right, that is our optimal P. We've solved for P star. This is the price in the market. That's the price in the market. So then we've actually solved that. We can put P up here. 2 of our 6 are down. Now what we need to do, Now what we need to do is take this P, plug it back into these values, and when we do that, we will be able to get all of our C's and B's. All right, so let's do that one by one. This is now step 7. All right, C1 star equal to 1 times 8 plus 2 divided by 2 times 1. So that will be 10 divided by 2, that's 5. All right, so C1 is 5. All right, let's do C2. That is P is 1, so it's 2 plus 8 divided by 2. So that's 10. Okay, so that's 5. B1 star, plug in P, so that'll be 8 plus 2 divided by 2. That's, again, 5. And then lastly, 2 plus 8 divided by 2, that equals 5. All right, so all the answers are 5. So in this equilibrium, person 1 consumes 5 bowls of cereal and 5 bagels. Person 2 consumes 5 bowls of cereal and 5 bagels. The price of cereal is 1. And so the price of cereal is 1, the price of bagels is 1. And when the prices are 1 and 1, they will trade to the point where both of them will consume 5 bowls of cereal and 5 bagels. Okay, so that's kind of the procedure for solving for a competitive equilibrium. We have now done it. An equilibrium, an efficient equilibrium, is where all the trades have been made, all the voluntary trades have been made, and the market has reached the point where agents consume 5 of all the goods. Both agents consume 5 of both goods. And the prices for each good is 1. All right, so that is an equilibrium solution. Okay, so now, having seen that solution mechanism, all you need to do to solve these kinds of problems is to follow those steps. So all we need to do is to solve those steps. Okay, well, with that said, I will leave you to it. Good luck with the homework, and I will see you in class.